Welcome back to Miss Eddie's Math Movies, where it's cute to be a square. Today's lesson is 11.3, Arcs and Central Angles. By the end of the lesson, you'll be able to find the measure and the length of arcs and the measure of central angles. We're going to start with semicircle. It's going to be kind of our reference here. A semicircle is half a circle, which is 180 degrees. So we can draw a picture of that. So here's your full circle. You always want to look for diameters because diameters cut circles in half. So this is a semicircle. Minor arc and major arc. Now minor and major kind of know what they sound. Minor is smaller and major is bigger. So a minor arc is less than 180 degrees. And a major arc is more than 180 degrees. So if we were to draw a picture for both of these, the minor arc would be less than half the circle, maybe that, and the major arc would be more than half the circle. For example, that. The measure of the minor arc is the same as the measure of its central angle. It's equal to the measure of its central angle. You remember, central angle is an angle that's right in the center. So here's a central angle right in the center. This arc has the same degree of that angle. So if this arc is 70, or this angle 70 degrees, this arc is 70 degrees. This is talking in degrees. Please write that here, degrees. Down here we're going to talk about the length of the arc, and that's going to be in inches, feet, centimeters, etc. So here we're talking about degree. So measure and degree go together. Length goes with these units. So keeping that straight. The measure of the major arc is 360 minus the minor arc. So for example, if I want to know how many degrees are here, well, I need 360 degrees in a circle. I'm subtract what I already have. I already have 90. So that's going to give me what I need. 360 minus 90 in this case is 270. Congruent circles are circles that have the same radius. Congruent arcs are arcs that have the same measure and length. So the same degree and the same length. Now we need to talk about how to name these things. So I'm going to draw a circle up here. Let's put some points on it. A, B, C, and D. All right, and so to name a minor arc, you have to use 2 points. If you pick 2 points on the circle, for example, AB would be a minor arc, or BC, or CD, or even BD looks like it's pretty close to half, but I think it's a little bit less. A major arc, you have to use 3 letters. You always want to take the shortest distance. So for a major arc, I need to go more than halfway around. So I could say A, D, B. If I just say AB, I'm thinking it's this. So you need to put a third letter in there. A major arc would be A, D, B. Go to A, go to D, go to B. And then a semicircle, you have to use 3 letters. So it's okay. It looks like a diameter. We could put a diameter here. So a semicircle is going to be A, B, C. And notice you put an arc above it. Not a straight line, no arrows, just an arc symbol. And that's how you name arcs. Name the type of arc that has the measure described below. Then tell how many points are used to name this type of arc. So less than 180 is a minor arc. And we need 2 points to name a minor arc. Just like up there we said AB. Equal to 180 is a semicircle. And you need 3 points to name a semicircle. You got to tell me which way you want me to go around the circle. Which half do you want? Notice you put an arc above it. And greater than 180 is a major arc. You must also use 3 points to name a major arc. And we use the example of A, D, B. That was from our circle from above. Name the gray arc and identify the type, then find its measure. So we've got a few things to do here. We have to name it, identify the type, and find the measure. So the name, here, this is the gray arc here if you can't tell. The name, it starts at D and it goes to F. So that we named it. Now what type? Well, that's definitely less than 180. That's a minor. And we learned that the degree is the same as the angle. So it's a minor 40 degrees. Now here, this is the gray arc. It's hard to tell on your copy. So we need to name it. So we're going to go from L to M to N, or you could go this way if you want. We have to use 3 letters, L, M, N. This is definitely covering more than half the circle. So this is a major arc. But how many degrees are there? Well, I know there's 360 degrees total in a circle. I already have 110, so how many more do I need? Well, 360 minus 110 is 250 degrees. It's a major, and we gotta take away that to get 250. That's definitely bigger than 180, so it's confirmed that it is a major arc. Arc addition postulate. You remember before we had segment addition, which said when you take 2 small segments and you add them together, you get a longer segment. And we had angle addition that said when you add 2 smaller angles, then you have the total of the larger angle. Well, it's the same idea here. If you want to find the larger arc, you can add the 2 smaller arcs together. So if you want to find the degree from A to C to B, well, you can take AC and add it to CB. You can sum the arcs. Little arc plus little arc equals big arc. All right, down here, and I apologize for my copy being off a little bit. Hopefully you can see that. That's 40 and 80. Find the measure of G, E, F. So I got to go from G to E to F. Trying to find all of that. Well, here I've gone 40 degrees, 80 degrees, and 110 degrees. So that's a total. We can grab our calculator if we need to. 40 plus 80 plus 110. 230 degrees we traveled. All right, that means that according to me, there's 360 degrees in a circle. According to what I'm thinking, this has to be 130 here to get all the way around. That was just some extra for you. Find the measures of the gray arcs. Are they congruent? So here's one gray arc, another gray arc. So we want to make sure they're congruent. If you flip back, congruent arcs have the same measure, same degree, and the same length. Oh, and here, arc length is a portion of the circumference. So, the same degree and the same inches, feet, centimeters, whatever the length is. So here they're both 45 degrees, and since they're in the same circle, they have the same length. So they're in the same circle, that means they have the same length, they have the same degree, so arc AB is congruent to arc DC. Now look at, here's these two gray arcs, XZ and ZW. Well, they both go with an angle of 65, so they both have the same degree, right? So we have to check, is the degree the same? And is the length the same? Here it was. Here, is the degree the same? Yep, both 65. But is the length the same? No. Notice this is much smaller in a smaller circle than this. The circle has to be the same for both. So XY is not congruent to arc ZW. Checkpoint. Find the measure of the arcs in circle A. Are the arcs congruent? So you just have to find out how many degrees, yes or no. I want you to do this now. Now let's see, if we want to find this angle right here, think about it. We've got 360 degrees in our circle. How many degrees are we missing? That's going to help you find DE when you get there. Arc length corollary. Now we're talking about length, how long something is in inches, centimeters, etc. And to do this, I'm going to have you write a proportion. So you're going to do arc length over total length equals arc degree over total degree. This is the proportion we're going to write. Notice it's portion to total, portion to total. And the total length we call the circumference. The total length around a circle is the circumference, which is 2r pi. And the total degree around the circle is 360. So that's what we're going to use for the next problem. Find the length of the arc. All right, so here's the gray arc. We need to find how long it is. So we're going to do part over total. Well, the total is the circumference. Remember, circumference is 2r pi. So 2 times r is 5 is 10 pi. And we do degree over total. We've done this before with area. Now we're doing part of length, total length. Part degree, total degree. X equals. So 10 pi times 50. Oh, here you go. 10 pi times 50 divided by 360. 4.36 centimeters. So notice we're talking about length now. We need to have units, not just the degree. So part, this part, over the total circumference, which is 14 pi, equals 50 over 360. Part to total, part to total. 6.11, and we're still in centimeters. I've already done this one for you. Part over total, part over total, cross multiply and divide. Now I want you to do these checkpoints just like I did above, just like example 4. Don't forget your units and write a proportion. This is M cubed, signing out.